The topic of my presentation is how secure is an object storage? The background to this question is that more and more customers are looking for a way to copy from an object storage, to copy data from an object storage to an independent device. Or in other words, customers are looking for a backup solution for object storage. The surprising fact is that backup is actually an absolute must, but has so far been ignored for object storage. And the second topic is storage tiering, which is also a standard in the IT world, but not for object storage yet. If you don't know us yet, a few facts about Point Software and Systems. Point is an independent software vendor for data and storage management solutions, founded in 1994. Our entire team, the product development, the support team, or sales, pre-sales, we're all located in Germany, in Siegen, which is about an hour from Cologne. We have small customers who manage a few terabytes with our software solutions, and also very large customers with several petabytes. We have a worldwide reseller network, and we work closely with the major storage vendors like NetApp, Dell EMC, Quantum, Hitachi, or Claudia. Let me begin with the question, how secure is cloud or object storage? When you have a look at object storage vendors like NetApp with their storage grid, or for example, Claudian with their hyper storage systems, they highlight the availability. In the technical specs, you will typically read a percentage representing the system uptime, for example, something like 99.99%. On the one hand, there are hardware-related data loss scenarios like disk failures, node failures, or even a site failure. All these failures, all these hardware-related failures, can be covered by erasure coding or replication to different sites. But on the other hand, there could be software errors, a malicious deletion, or ransomware. And most people think ransomware only attacks file systems, but we know there are concepts how to attack an object storage, and we think it's just a matter of time before this problem arises. And then there's, of course, the human factor. For example, the IT administrator who has configured the permissions for an S3 bucket incorrectly. You will find a lot of cases about this in the press. To protect against these scenarios, you need a backup of your object storage. But of course, the question is how to do that. The second challenge is about storage tiering for object storage. As we all know, an on-prem object storage is hard disk based, and it contains a lot of very large hard drives. A good starting size for an object storage is typically in the high three-digit terabyte range, but mostly we see installations in the petabyte range, often 10 or even 20 petabytes. So the question is, how can you move your inactive data or your inactive objects to a low-cost storage for long-term retention? When you have a look at the hyperscalers like AWS or Google, you will notice they offer different storage classes. They have a standard class for the for general purpose and additional classes for infrequently accessed data. Especially offerings like Glacier or Glacier Deep Archive are extremely inexpensive. But the retrieval of data takes much longer. For example, with AWS Glacier Deep Archive, it takes by default 12 hours to retrieve data. We do not know the exact underlying hardware technology which is used by AWS or Google. But in case of Microsoft Azure, we know this. Microsoft has checked different technologies like Blu-ray, but finally they came to the conclusion that tape is the best option. And this shows you should stop the discussion tape versus cloud, because finally your old inactive data, your inactive objects will end up on tape. And this leads me to our solution. The point archival gateway is basically an object storage with all the benefits like erasure coding, scalability, high availability, but the archival gateway stores data on tape instead of hard disk. And as a result, the storage becomes very economical and perfect for long-term retention. You can also call the archival gateway a secondary object storage or an additional S3 storage class for inactive data. Similar to what the hyperscalers do, the point archival gateway allows you to offer different S3 storage classes, because the archival gateway provides a native S3 API. You don't have to adapt your software. Yeah, so it is compatible to the AWS S3, including versioning, without any proprietary commands. And the gateway supports LTO Gen 5 to Gen 8 drives and the IBM Enterprise drives as well. By adding nodes to the point archival gateway, it scales the performance and in high availability at the same time. And we use erasure coding when writing to the tape media, and we support different settings like 1+1, which is actually mirroring, yeah, or a setting like 3+1 to improve throughput. Yeah, I think the numbers here in my slide perfectly shows how powerful this solution is. We support up to 8 libraries, 8 tape libraries in parallel, up to 256 drives. Yeah. So you can achieve a maximum throughput of 230 gigabyte per second. When you use multiple libraries, they can be in the same site or in different locations. Then you can configure cross-location mirroring or cross-location erasure coding. It is supported as well. So here are the system components. And as I've already mentioned, the point archival gateway scales by adding nodes, and we have 2 types of nodes. The first one is the so-called database node, or DBN, which is responsible for the administration, the entire management, and of course the library robotic control. The management includes an extensive user management where you can create local users, or you can work with your accounts from your Active Directory or different LDAP-based directory. And by the way, the administration is web-based. Yeah, it's all HTML. And then the second type is the interface node, yeah, which is responsible for the S3 communication and the write operation to the tape. Yeah. And you can have multiple of them, multiple IFN nodes for load balancing and high availability. And then we have three networks. First of all, the network for the S3 client communication, which is at least 10 gigabit per second. And then there's the internal network for the node communication. And finally, the fiber channel network to connect the drives and robotics to the nodes. In small environments with a few hundred terabytes only, we can start with a single node solution, which combines the interface and the database service. We call this kind of setup compact edition. And in many cases, we start with one compact edition, or we add a second one for the availability. Let me use this graphic here to explain the architecture. Starting at the bottom, we call a tape library internally archival storage device, and each cartridge is an archival storage volume. A protected volume array, or PVA, is a set of tapes depending on the erasure code rate. It can consist of 1 to 4 tapes. And we take multiple PVAs to create a partition, which is just a logical unit. And then we create the S3 buckets in that partition. When you define your erasure code rate for a partition, the allocation is not limited to one library, but we can take multiple libraries to distribute the erasure code segments to different libraries. And as I've mentioned before, you can implement this within the same location or with multiple locations as a stretched cluster configuration. Next, I would like to give you an example for the erasure coding. In this case here, it is 3+1 erasure coding. First of all, the application or the S3 clients send data as an object stream to the point archival gateway. Then we do a segmentation of the stream. Then we do the encoding. So in this case, we have here we have 3 segments of data information and 1 segment containing the parity information. And finally, we write the segments to different tape media. When writing to the point archival gateway, we expect a sufficient throughput from the S3 clients to do an optimal streaming to tape. So by default, we don't use any staging or caching. It's all system memory based, yeah, based on the RAM. of the system. So at least one object, one entire object or piece of a multi-part upload must be loaded into the RAM before we write to tape. So, but if this is not the case, for example, you have very small objects and just a few parallel sessions. For these cases, you can enable our persistent buffer. This is a feature, and so we buffer the objects first of all on a hard disk, and then based on a threshold, which can be volume based or age based, we flush the content of the buffer to tape. Yeah. So, but this also happens via the RAM to write with full speed to the tape drives. Yeah, and here's the read path. Important to know is we will utilize only as many drives as necessary for the read access. So in this case, with the 3+1 Erasure coding, we would use 3 drives for auto tapes for reading data. Here you can see some use cases. To back up an existing hard disk-based object storage, you can use the cross-region replication or CRR. If your storage supports this, or we can provide our point data replicator, which works independently of the source system. So the data replicator also has the advantage that the backup solution can be run in an isolated environment. And if necessary, you can read directly from the point archiver gateway with your S3 client, or you can reverse the replication direction. And we can use the point archiver gateway for storage tiering, yeah, from your hard disk object storage to tape. And this way we can offload inactive data or objects to an extreme inexpensive storage technology and of course optimize cost. We have tested the point archive gateway with NetApp Storage Grid, with Claudian Hyperstore, Hitachi Ventera, HCP, and Scality Zenko. For the tiering, we use the existing features like the NetApp Information Lifecycle Management, the ILM, and then you register the point archive gateway as a target, and then you can define rules to move objects older than a specific date and so on to the point archive gateway. It's very similar with Dell EMC Isilon. There you can also define rules to move data. And we have also tested it with the Hadoop file system. And yeah, because of the native S3 API, it is compatible to any S3 client. I think it's important to know when you use the archival gateway for multiple workloads, then you have many options to configure this. For example, you could create a dedicated bucket for each workload, but all utilize the same partition and so the same tapes. Or you can configure individual partitions, so you can also divide the data on the physical tape level. This way you can also choose different erasure code settings for each workload. You see there are many, many different ways to configure. Okay, yeah, I think that brings me to the end of my presentation. Thank you for your attention. And before we move on to your questions, I would like to mention our website where you can download the Point Archival Gateway white paper.